Hi Stats, this is 6.2 notes and this is part 1. We're going to do a little bit of review today about those normal curves because we're going to be using them in 6.2. So back in chapter 2 we learned about the normal curve, and some of our continuous variables will be a normal curve type of problem. So let's just review it. So I've created a normal curve graph for a golfer's distance when they hit a ball. Follows a normal distribution. It has an average of 150 yards with a standard deviation of 30 yards. So if you remember, everything within one standard deviation counted for 68%, right? Then everything that went within one standard deviation counted for 95%, and then everything that went between two standard deviations counted for 99.7%. Okay, so those were our normal curve distributions, right? So we're going to use some of those and just double check. So it says, what is the probability that the golfer will hit the ball more than 180 yards? So we're looking at them and trying to say, what is the portion underneath this curve? What's the area underneath this curve? And the area relates to the probability. So then all I have to do is I have to add up 13.5 plus 2.35 plus 0.15%. And if I do that, I should have 16%. Cool. All right, let's go do the next one. So the next one is, what is the probability that if a golfer hits a ball, it will land between 120 and 180? So that's between here and here, right? So again, I'm just going to go and add those all up, and I'm going to get a 34 plus a 34, and that's going to be a 68%. Okay, what about if we want at least 120 yards? Well, then that would be both of those added together going all the way up here. Or I might decide it's 50%, which is this part right here, and then add in this little part, 34. So 50 plus 34 should be 884. Right, and that should be the same thing as adding the first two problems together. Okay. All right, so let's try part D. So part D says at most 162 yards. Okay, 162 is not on my graph. It's going to be somewhere around here, and they're saying at most. So they're saying like it starts there and then goes this way forever. Okay, I can't figure this out. It's not proportional. It's not like I could figure out what portion it is from 150 to 180 and then take that part, because my curve is not a rectangle. I can't use proportions to solve this. So we have to convert to z-scores for this, and we need to go and look at a table in our book. It's in the back of the book. Okay, so the first thing is we're going to convert it to a z-score. So how do we convert it to a z-score? Well, remember the formula was you take your x minus your mean all over your standard deviation. So I've already done that for you. 162 minus 150 all over 30 is a positive 0.4. Okay, so when I go and look at the table will only give me numbers as what's shaded, which is it always starts at the left and it goes up to the point you ask it to. Okay, so I'm going to go look for 0.4 because that's exactly what I want. I want less than, up to, and including 162. Here is the 0.4 row. So this would be where 0.40 is. This is where 0.41 is. This is where 0.42. You get the idea. Okay, so I'm looking for a 0.4 exactly. So I'm going to pick this first amount as my probability. So I'm going to say that my answer from up there is going to be 0.6591 is the probability. So 65.91 probability for 162 yards. All right, so do you remember what the 0.4 was as a z-score? It just tells us how many standard deviations we are above or below the mean. How many standard deviations we are, our value is at, above or below the mean. Above if it's positive, or below if it's negative, the mean of the distribution. Okay, so this is what they would do in olden times. We have a graphing calculator, so we can have our graphing calculator do this part and not have to worry too much about that. Okay, so here are the steps I'm using our graphing calculator. Okay, so I'm going to go and move the graphing calculator into this window, but beforehand I want to make sure that you see what we're doing. We're going to be doing second vars, and then we're going to pick number 2, which is going to start out with this word, normal CDF. CDF means continuous density. meaning we're going to add up a whole bunch from here until there. And then we put in whatever our low z value is, then our high z value. So like start and then stop here, stop here. And we always do it in number line order, so it's always lowest first. Okay, then we put the mean z, and the mean z is always a 0 if it's a z-score, and the standard deviation if it's a z-score is always a 1. So those two parts will always stay the same. Now we have a couple problems in that r starts at negative infinity. So either I could use it according to the problem. So what do I think the lowest amount that they could probably hit a golf ball is? Probably 0. But then I have to look at every single problem and think that through and go, what's the lowest I could have? What's the highest I could have? So I cheat. I just always use a really, really humongous negative number. And then I always use a really, really humongous positive number for positive infinity. My favorite ones are either positive or negative 10 raised to the 10. Now, depending on your version of your calculator, if it gives you an error for like overflow or something, then that's too big. You need to make it a little bit smaller. So you could maybe do negative 10 to the 9th power or the 8th power. Okay, so I'm going to basically be putting into my calculator all this, and hopefully we're going to get that exact same answer. So let me see if I can bring that one into our screen. Okay, and let's go and look at this one. So we are going to go, we're looking for this vars, but we want the blue distribution above it because we're dealing with normal distributions. Okay, so I'm going to go down to number 2, which is cumulative. We always want to use cumulative. The one above it is a point. It's only finding one x value in the area above it. And if you're in calculus, you know that that is very, very small, infinitesimally small, unless we're dealing with discrete numbers, whole numbers. So we really don't use PDF and stats. We really are looking at a normal curve. We're coloring in on a normal curve because it's continuous. So I'm going to pick that one, and it says, what's my lower amount? So I want to put in the lowest amount possible. That is 10, negative 10 to the 10th. Okay, and then my upper is going to be whatever my z-score was, which was 0.4. Okay, and then my mean is a 0, and your standard deviation is a 1. Now, the first time you ever do this, the mean and the standard deviation should already be set to 0 and 1. So we're not really going to change that. So then I press enter. This is what the formula looks like. So if you don't get the option of having that menu come up, it's going to put normal CDF on your screen right away and open up the parentheses, and then you just have to know what the order is, low to highest, and then mean, and then standard deviation. Okay, and then if I hit enter for this, there is my area under the curve, 0.6554. Okay, so this is the way I usually use it. Now, there's another way I could use this as well, and that is to still do number 2, but to move over 1 for the draw part. Okay, so I'm going to shade normal instead, and I could tell it to draw it for me instead. So then I could do this, and I could say shade what. So I'm going from negative 10, they have negative 1 to the 99th power, that works too. Negative 10 to the 10th. My upper amount was that 0.4 z-score, and then I'm good there. And this happens to be a color one, that's great. And it looks like I've got something else in there, but you get the idea, right? So I should have pressed a zoom for one, so let's go clean that up. We'll take this one off. All of those others are fine, so I want to do zoom stat. Oh, I have to go back and redo it. How sad. Okay, second distribution. Go over to draw, shade normal, negative 10 to the 10th. Our upper is 0.4, and the rest is fine. And I press draw. And there we go. And again, it says underneath that this is 0.65542. Now you notice it didn't go all the way off to the other side. This is the actual normal curve. So I could have, all right, so that is the way we put it into our calculator. I was going to go back and try to adjust the window some, but then the graph goes away and I have to put in all the stat steps again. So I stopped that. All right, so back to our notes. So we can see that I can get that same exact number from my calculator. Awesome. Okay, so the next thing we're going to do is we're going to use these for a few places where we're not going to necessarily always get those standard deviation markers. So this one says use a normal curve below to show all three values if the mean is 16 and standard deviation is 2. Okay, so they're basically saying, can you just fill this in this chart? So in the middle, our average is 16, our standard deviation is 2. So this would be 18, 20, and 22 to go out 3 standard deviations, and 3 standard deviations this way would be 14, 12, and 10. Okay, so we've got everything labeled. Then part A says, what is the probability that the value is no more than 19? No more than 19. So 19 is right about here. So no more than is we want it to go this way forever, but then approach here to 19 and then stop at 19. Okay, so that is not where one of my standard deviations is, so I can't use my 68, 95, 99.7. So I'm going to have to go and find a z-score. So the z-score is going to be 19 minus 16 over 2, which is 3 over 2, which is 1.5, I believe. Okay, so we are going to go and do norm CDF starting at negative infinity, going up to 1.5 when the mean is 0 and the standard deviation is 1. All right, so I'm going to go bring that back into our screen here. So second bars, normal CDF, we're going to start at negative 10 to the 10th. And then we're going to go, hey, where'd my thing go? That's fine. I want to delete back one. Okay, and then I want to do a comma. And then after that, I'm going to go to 1.5. And then a comma. And then I'm going to go to 0 and 1. And press enter. And it looks like 93% around there. So I'm going to write 0.933, which is about 93.3%, which kind of makes sense because if you take a look at it, right, it's more than halfway. It's all the way over towards the other side. That totally makes sense. All right, let's take a look at another one. What is the probability that the value is between 11 and 15? So 11 is all the way down here. 15 is right about here. So they're asking us to find this portion right here. So again, I have to go to a z-score. Now this time I'm going to have to find z-scores for both. So the first one is 11 minus 16 over 2. That is negative 5 over 2. That's negative 2.5. And then the upper one is 15 minus 16 over 2. That's negative 1 over 2. That's negative 0.5. So when I go to do this one with norm CDF, I'm going to start at negative 2.5 as a z-score, go up to negative 0.5 with a 0 and a 1, and figure out what that amount is. So this one, I'm not expecting it to be more than 50% because it's already in the lower portion. Okay, so I'll bring this one back in, clear all that out. We'll go to second bars. We'll pick the second one off. And this time we're going to go from negative 2.5 to negative 0.5. And then I can leave the rest of them the same, so I'm just pressing enter. All right, and now I've got a 0.302, which is about 30.2%. And again, you can write these answers as a decimal or as a percent, right? Probability can be done either way. Awesome, so that's our main review, and also showing you how to use the graphing calculator to help you find these. All right, that's it. We'll start 6.2 in the next one.